Well, greetings, chemistry classes. Today we're going to be looking at our Chapter 11 review on stoichiometry. And the key for our chapter review on stoichiometry is just this idea of the concept of mass, converting to moles, converting to moles, converting back to mass, where we're going to use our periodic table to convert from mass to moles. From here, we can use our balanced chemical equation. This is the only time it's used is when we go from the moles of one substance to the moles of another substance, a chemical reaction, and then periodic table again, going from the moles of one substance to mass of another substance. So to begin with, we're going to complete the following table. First off, we've got aluminum oxide. It's going to produce oxygen and aluminum, the decomposition. So first off, to balance, 3 oxygens, need the 2, need the 3 to get 6 oxygen each side, and then our 4 aluminums to balance out. So number of particles, remembering our correct units. So for aluminum oxide, we're going to have 2 formula units of aluminum oxide, because we have a metal and a non-metal coming together there. From there, 2 nonmetals. So we'll have 3 molecules of oxygen, and Al, just an atom, we'll have 4 atoms of aluminum there. From here, moving down, number of moles, we just have 2, number in front, moles of our substance, 3 moles of our substance, and finally 4 moles of our substance. And then when we look at a mass of each substance, so number of particles, note number is the same between each. Mass of each substance, using our periodic table, there are 2 moles of our substance, Al2O3, so using the periodic table 2 times, we have 101.96 grams total. So our total in the end, 203.92 for both of those combined. 3 times 2, we have 6 oxygens. 6 oxygens times its mass, 16.00. We get 96 grams of oxygen, and 4 for aluminum times a 26.98. We end up with a total of 107.92 grams. So total mass of reactants, 203.92 grams. And then on this side, the total of both of those added together would be 203.92 grams. So conservation of mass, mass of reactants, total mass of the product. So why we need that balanced chemical equation. Our second problem, continuing that mass, mole, mass idea, if we start with 2.34 moles of sodium bicarbonate, baking soda, it's going to decompose, so 2 moles sodium carbonate, and it's going to 1 mole to 1 mole to 1 mole ratio. Note we're starting with moles in this time, and we're going to move how many moles can be produced. So we're moving from mole to mole ratio. So our starting point, we've got 2.34 moles of sodium carbonate, HCO3, and we're just going to move into the mole to mole ratio, in this case from moles of one to moles of the other, so 2 moles of our sodium carbonate, or sodium bicarbonate, excuse me, over 1 mole of sodium carbonate. So units on the bottom will cancel, leaving us with the desired unit of the sodium carbonate, numbers on top multiplied, divided by that number on bottom, and we get 1.17 moles of sodium carbonate. In the second question, it's asking if we had the 2.34 moles, how many grams could we produce? So we're starting with moles, we're in a mole to mole ratio, and now moles to mass of the substance. So starting in the same idea, 2.34 moles of sodium bicarbonate. Our first step is we're already in moles, so we can just go mole to mole ratio of H2O. In this case, we have 1 mole of H2O over 2 moles sodium bicarbonate. And now we want to go for moles of water, 1 mole always over its mass on the periodic table, 2 hydrogens and 1 oxygen, gets us to 18.02 grams of water. Numbers on top multiplied, divided by the numbers on bottom, so we can cancel out, leaving us with grams. In this case, we get about 21.1 grams of water being produced if we started with that 2.34 moles of water. 2.34 moles of sodium bicarbonate. Question 3. How many grams of iron 3 oxide are produced if 30 grams of iron react with excess oxygen? So right now we know we have 30 grams of iron and we have excess oxygen, so we have more than enough. The question is, how much iron oxide are we actually going to make from this reaction? So our first step, to start with a balanced chemical equation, getting our oxygens balanced first. 6 oxygens, 6 oxygens, 4 to get our irons balanced, 4 of each irons. So step 1, we're going from mass to moles, mole to mole ratio, mole back to mass. So we're starting out, we have 30 grams of iron. So our first step is we need to go from grams to moles. 1 mole of iron is 55.85 grams of iron from the periodic table. Once we're in moles of iron, we can do our mole to mole ratio. 4 moles iron is going to be the same 2 moles of Fe2O3, iron oxide. So note, grams would cancel the grams, our moles would cancel our moles. Now we're in moles of iron oxide. However, we want to see how many grams, so we need to go mass to mole to mole, and moles back to mass. So our last step is going to be using periodic table. 1 mole of iron 3 oxide is going to be equal to 159.07 grams of iron oxide. In the end, numbers on top are multiplied, and then afterwards divided by the numbers on the bottom. In the end, we get about 42.9 grams of iron oxide. So this would be our mass, mole mass problem. Now, a couple of other questions. Is this amount actual or theoretical? So theoretical yield, what would we look at? This is a calculated value. So not done in a lab setting or in lab. So it's a theoretical, not what you actually calculate, but in theory what you should get. I'll explain what it is meant by having excess oxygen. Excess oxygen, you have more than enough. So when you look at that, it's not going to stop the reaction. So we had more than enough oxygen in order for this reaction to actually occur. If 7.85 or 7.8 grams of oxygen react with excess hydrogen, how many liters of H2O will be produced? Now, a couple of things here. Instead of being mass, mole, mass, we want to end in liters, which is going to be a volume. 1 mole of any gas at standard temperature and pressure equals 22.4 liters. So that's going to be a conversion that we're going to need at the end, not at the beginning. So we look at our problem here. If we were to start out with balanced chemical equation. Starting out 2 and 2 to balance our oxygens first and to balance our hydrogen second. So if we were to start out 7.81 grams of O2, we first need to go grams to moles always. 1 mole of O2 is 32.00 grams of O2. Once we're in moles, we can do our mole to mole ratio using balanced chemical equation. We want to go to H2O, so 2 moles of H2O over, start out 1 mole of oxygen. Once we're in moles of oxygen, our moles of water, now we're going to use our 22.4 liters to get into our volume, our molar volume. 22.4 liters of any gas, O2 in this case, is the same as 1 mole of O2. Of H2O. Of H2O gas. Sorry about that. So fix that up real quick. 22.4 liters of H2O, same as 1 mole of H2O, switching our gases there. In the end, numbers on top are multiplied, numbers on bottom are divided. So we get 10.9 liters of H2O as a gas. So when we look through, going from mass to moles, mole to mole ratio, and then our change here, moles to molar volume, 1 mole is 22.4 liters, our conversion there. So now for a limiting reactant problem. If we have 25 grams of sulfur going to react with 25 grams of oxygen to produce sulfur trioxide. So our idea is going to be what's our limiting reactant and who's our excess reactant in making this product. So to begin with, 3 and 2, and finally 2 sulfurs to start with our balanced chemical equation. We have 25 grams, and we have 25 grams of each of these substances. The question is, how many grams of the product are we actually going to be producing here? So we need to do 2 conversions, mass, mole, mole, mass, starting with sulfur to see how much sulfur trioxide we'll make, and then from there, how much oxygen we have and how much sulfur trioxide we can make. So 25 grams of sulfur, 1 mole of sulfur, always the 1 mole, over 32.06 grams sulfur from the periodic table. Once we're in moles of sulfur, we can go mole to mole ratio. In this case, 2 moles of sulfur trioxide over 2 moles of sulfur. And once we're in moles of our other product, the periodic table, mass of sulfur trioxide, 80.06 grams SO3 is the same as 1 mole of SO3. So units on the top cancel, moles of sulfur, and we're left with grams of sulfur trioxide. In this case, 62.4 grams of sulfur trioxide would be produced. So our other reactant, 25 grams of O2, 1 mole of oxygen over 32.00 grams of oxygen from the periodic table. Setting up now our mole to mole ratio, 3 moles of oxygen to 2 moles of sulfur trioxide. And then from there, we need to move back to grams. The same 80.6 grams of sulfur trioxide from the periodic table is the same as 1 mole of sulfur trioxide. Numbers on top are going to multiply, numbers on bottom we divide, and in the end we get about 41.7 grams of sulfur trioxide. Now thinking back, like in the cookie lab, whichever makes a smaller amount is going to be our limiting reactant. So whichever one makes a smaller amount, our smaller amount in this case, the 40.07 grams, so our oxygen is our limiting reactant. So what reactant is our limiting reactant? Oxygen. And what reacts as an excess would be the other one, sulfur. So from there, what is the mass of the product produced? 41.7 grams of sulfur trioxide. Our last question then is, what is the mass of leftover reactant? We're going to use that as our starting point. 41.7 grams of sulfur trioxide is how much we could produce. So our question is, if we can go back from there, how much sulfur would we need to make this much? So our first step, going back to grams, or back to moles, 1 mole sulfur trioxide, periodic table, 80.06 grams of sulfur trioxide. Once we're here, our next step is we're going to go moles of sulfur trioxide to moles of sulfur. 2 moles sulfur over 2 moles sulfur trioxide. And then finally moles back to mass. 32.06 grams of sulfur over 1 mole of sulfur. Knowing that, numbers on top multiplied, numbers on bottom are divided, it comes out to 16.7 grams of sulfur would be needed. Since we had 25 grams of sulfur to start with, 25 grams sulfur minus the 16.7 grams of sulfur needed, the excess, or what would be left over, 8.3 grams of sulfur would be left over. So in the end, while we're working through this, we solve for our limiting reactant. Who is going to stop this reaction? Oxygen will. Excess reactant, sulfur. How much of sulfur is left over afterwards is based on how much sulfur trioxide we could produce to show how much sulfur we needed. Once we had how much sulfur we needed, the difference between our beginning and end gave us how much was left over. And our final problem for today, if 10 grams of silver react with 10 grams of chlorine, what is the percent yield of a silver chloride when only 8.4 grams are recovered? Hint, we'll start by finding the limiting reactant, which is the theoretical yield. In theory, how much can we actually make? So that'll be important at the end. So we need to start off with our mass, mole mass problem. 10 grams silver. Before we go any further, 2 chlorines. 2 chlorines. Won't need any number there, so just the 1 for chlorine. So 10 grams silver. Our first step, always going grams to moles. 1 mole of silver is equal to 107.87 grams of silver. Once we're in moles, mole to mole ratio, we can move between moles of silver and moles of silver chloride. 2 moles AgCl over 2 moles AgC, or Ag. So moles have canceled moles, grams have canceled grams, and now we're in moles of AgCl. Our final step then is to go back to grams. How much mass can we produce? 143.32, oh, excuse me, 32 grams of AgCl from the periodic table over 1 mole will show us in the end that we can make 13.3 grams of silver chloride. The other part is how much chlorine. So if we have 10 grams of chlorine, Cl2, our first step, 1 mole of chlorine. On periodic table is going to be our 70.9 grams of chlorine. Once we're in moles of chlorine, mole to mole ratio, 2 moles of silver chloride to 1 mole of chlorine. And our last step, same periodic table, 143.32 grams of silver chloride is 1 mole of silver chloride. So in the end, it shows that we can produce about 40.4 grams of AgCl. So looking at these two, the number that's the smaller amount is going to be the limiting reactant. Silver is going to limit how much you can produce, so the maximum amount we could produce from this chemical reaction is 13.3 grams of silver chloride. Now in the problem, it says that 8.42 grams were actually recovered. So theoretical and actual yield. Actual is what we cover, so that's from the lab recovery. Theoretical is our math portion, so what we should actually get. So if we go to percent yield, we'll look at that actual yield, what we did recover, 8.42 grams of silver chloride. What we should have gotten, in theory, how much was produced or should be produced from the chemical reaction was 13.3 grams of silver chloride. Percent yield times 100. So in the end, 63.3% is actually how much total we recovered or got compared to how much we should have gotten with our percent yield. So every chemical reaction is different. We could have lost some of it not reacted. So that is the reasons why we might not get 100% for this reaction. This wraps up our stoichiometry chapter. Remember the idea, mass, mole, mole, mass. Safe travels to everyone.